Hello, welcome to the Argo course. My name is Mohammed and I'm very happy to be here. In this session, I want to talk about Argo CD Applications set. But what is that? Let's go to the terminal. I'm in Argo CD namespace by default. You can change the current context to point to Argo CD namespace if you want. So when I type kubectl git pod, I will see the pods related to Argo CD namespace. Very good. One of these pods is this, Argo CD ApplicationSet Controller. But what is that? This controller enables both automation and greater flexibility managing Argo CD applications across a large number of clusters. The ApplicationSet Controller works alongside an existing Argo CD installation. Starting with Argo CD version 2.3, the ApplicationSet Controller is bundled with Argo CD. Let's imagine that we have 3 different clusters in Argo CD environment. Cluster A, Cluster B, and Cluster C. I want my application to be deployed in these clusters. To do that, the first solution to do that is creating 3 different files, 3 different manifests. For example, we have a file called app.yaml. I want to deploy this application in the local Kubernetes cluster. Because of that, I'm using in-cluster value for this key name. Because of that, this application will be deployed in the local Kubernetes cluster. For the second one, we can create another application. We can create another manifest to point to the second Kubernetes cluster. For example, cluster B. We can change this value. And we can do that for the third Kubernetes cluster too. But it's not ideal. For example, we have 10 clusters. So it's not ideal. Because of that, ApplicationSet is helping us to fix this problem. We can write a single Kubernetes manifest to generate multiple applications. As you know, if you remember, we have a resource object in Kubernetes called deployments. Deployment manifest has a block called template, and we can define the spec of a pod under template block. So we have a deployment, and this deployment can generate multiple pods. And we have this block, template in ApplicationSet 2. Because of that, we can create a single Kubernetes manifest and generate multiple applications. We can define the spec of an application under template block. But how can we do that? Let's go to the Git repository of this course. We have a new directory called Argo CD Applications set-1. We have 2 different sessions for application sets. Because of that, this session is this Argo CD Application set-1, and for the next session, the new directory will be Argo CD Application set-2. Let's go to this directory. In this directory, we have a generator. I want ApplicationSet to generate applications. Because of that, we have multiple different generators in Argo CD. One of these generators is list generator. Generators, such as the list generator, are responsible for generating parameters. Parameters are key value pairs that are substituted into the template section of the ApplicationSet resource during template rendering. Let's open the first example. I want to copy the content of this manifest and paste it here. Very good. The first line is related to API version. The API version is argoproject.io/v1alpha1. In this time, we are using application set kind. The kind of an application is application. But in this time, we are using application set as a new kind. The name of this application set is list generator-example1, and its namespace is Argo CD. We have a block called template. This is so important. This is the definition of an application under template block. So this is the definition of an application. We are using project, source, destination, sync policy, sync options. So this is that application. This is the definition of an application. We are using this definition under template block. As you can see, we are using some different variables with this syntax here. We have a variable called path, URL, and clusters. So we are using 3 different variables: path, URL, and cluster. The target is, and the goal is, generating applications. So we are using a generator called list. In Argo CD, we have multiple different generators. One of these generators is list. In this list, we have 2 different elements. The first element is this, and the second one is this. We have 2 different elements. So we will have 2 different applications. Okay? The first application is using this name. The name of the first application will be local-application. It returns the value of this key. We have a key called cluster, and its value is local. So the name of the first application will be local-application. And the name of the second application will be external-application. Because in the second element, we have a key called cluster, and its value is external. So the name of the first application is local-application. And for the second one is external-application. We are using a key called cluster. We have 2 variables with the same name, cluster and cluster. But we are using 2 different elements. But what about path? We are using a variable called path. This is static, Argo CD Applications. And this is mutual between 2 different elements. But what about path? The first application, the path of the source of the first application is this: Argo CD Applications / directory of manifests. And the source of the second application will be Argo CD application / helm / nginx. So the name of these applications will be different, and the path of these applications will be different too. They are using two different paths as their source. But what about destination? The destination of the first application is kubernetes.default.svc. The URL, we have a key called URL, and its value is kubernetes.default.svc. And the namespace is cluster. The key, the value of this key is local. So the first application is using kubernetes.default.svc as its server and local as its namespace. And the second application is using this IP address as its server, as its URL, and it's using external as its namespace. So we are using list generator because we have some different key value pairs. In the previous versions of Argo CD, it was mandatory to use cluster and URL keys. But in the new versions of Argo CD, we can use different key value pairs. And this is not mandatory to use cluster and URL keys. Okay, let's copy the content of this manifest and go to the terminal. Let's create a new directory for this session. And let's go to that. Let's create a new directory here called list-gen generator. Go to that. app-1.yaml. And paste the content here. So we will have two different applications, as I said earlier. And we are using sync policy and sync options. So we don't need to sync this application manually. And the namespace will be created by Argo CD automatically. Okay. Let's save the file and let's apply this file. And this application has been created. Let's go to Argo CD Dashboard UI. As you can see, we have an application called local-application. We have a single application because the clusters, when I type Argo CD cluster list, I have only one cluster because I removed the new clusters. Let's delete this application set to add the new cluster before. I have a secret called secret-yaml kubectl apply -f secret yaml. So when I type Argo CD cluster list, we have two different clusters. Very good. So now let's go to list generator directory and let's apply this file again. As you can see here, we have two different applications. The first application is local application, and the second application is external application. We didn't create these applications manually. ApplicationSet helped us to generate these two different applications. Let's go to the terminal. When I type kubectl get ns, this is my local Kubernetes cluster, and Argo CD created a namespace called local. As you can see, the namespace is this cluster, and the value for the first application is local. So Argo CD created this namespace automatically. But what about the next cluster, the new cluster? This is the environment related to the new cluster. When I type kubectl get ns, Argo CD created a namespace called external, because the second application is using external as its as the value of cluster key. This is the first application for local Kubernetes cluster, and this is for the second application for the new Kubernetes cluster external application. Pretty good. Okay, it was about a list generator. We deployed applications using list generator to generate applications based on some different key value pairs. As I said earlier, in the previous version of Argo CD, it was mandatory to use cluster and URL keys. But in the new versions of Argo CD, it's not needed to use these keys. We can use another keys if I want. Because of that, we have another manifest called list generator example 2, and as you can see, we are using another key called environment. Instead of cluster, we are using environment and server. So we can use some different key value pairs as our needs. Very good. It was about list generator. Okay. The next generator is cluster generator. The cluster generator allows you to target Argo CD applications to clusters based on the list of clusters defined within and managed by Argo CD. In Argo CD, managed clusters are stored within secrets in the Argo CD namespace. As you saw earlier, we used a file called secret.yaml to add a new Kubernetes cluster to Argo CD environment. ApplicationSet Controller uses those same secrets to generate parameters to identify and target available clusters. For each cluster registered with Argo CD, the cluster generator produces parameters based on the list of items found within the cluster secret. The cluster generator will provide some different parameters that we can use in ApplicationSet manifest related to cluster generator. The first parameter is name. We can use these parameters for each cluster. The first one is name. If you see the secret related to the new Kubernetes cluster here, we have a key under string data block called name, and its value is external. Okay, so we can use this variable in ApplicationSet Controller manifest related to cluster generator, and it will return the value like this. We have another variable called name normalized. Name normalized. It's name, but normalized to contain only lowercase alphanumeric characters, and also it will convert underline to dash. For example, if the name is like this, test underline A, it converts test underline A to test dash A. It converts underline to dash. The third one is a server, and in a string data block we have a key called server, and its value is like this. It's IP address. So if I use a variable called server in the ApplicationSet manifest, it will return this value for this cluster. Okay. The another parameter is metadata dot labels dot key, and metadata dot annotations that key for each annotation and for each label in the secret. For example, we have a key called metadata dot labels dot environment, and its value is staging. Okay, very good. Let's go to the Git repository, and we have a new directory called cluster-generator, and let's use the first example. I copy the content related to the first example. I paste it here. Okay, in this time we are using a new generator called clusters. Instead of list, we have a new generator called clusters, and it's using an empty block. Very good. But what about template? As you can see here, this is the template. This is a definition related to application. We have a variable called name. Argo CD will detect all the clusters in Argo CD environment. For example, it will detect the first Kubernetes cluster, local cluster, and its name is this Argo CD cluster list. The name of the first cluster is in-cluster. So the name of the first application will be in-cluster-application. And for the second application, this is the second cluster. Its name is external. So the name of the second application will be external-application. We have two clusters, so we will have two applications. If we have 10 clusters, for example, we will have 10 different applications. The second variable is server. We are defining the server. We are defining the destination. The destination, the server for the first cluster is Kubernetes.default.svc, and for the second application, the server value is this IP address here. Very good. Let's apply this file and see how it's working. But before that, let's delete the files related to list generator. Okay, go to list gen directory and let's delete kubectl delete -f this file, and the application set has been deleted. Let's create a new directory here called cluster-gen and go to this directory. And let's create the first application set here. appset-1.yaml. Very good. This is the manifest related to cluster generator, and Argo CD will detect two different clusters, local cluster and new cluster. So we will have two different applications. The name of the first application will be in-cluster-application, and the second one will be external-application. kubectl apply-f appset1. The application set has been created, and as you can see, we have two different applications here: in-cluster application and external application. So Argo CD detected two different clusters and it created two different applications for each cluster. Very good. Sometimes I want to deploy my application in some specific clusters, in one or more specific clusters. For example, I want to deploy application A I want application A to be deployed in the cluster that has a specific label. So what can we do? In this situation, we can use selectors in cluster-generator to select some specific clusters for this purpose. Okay, because of that, let's go to the second example. I copy the content and paste it here. appset-2. Very good. And okay. In this example, we are using selector match labels. I want my application to be deployed in a cluster that has these two labels. A cluster that has these two labels: Argo CD Argo Proj secret type equals cluster and environment equals staging. Okay, I added the new cluster using this secret file. As you can see, I used this manifest to add the new cluster. Okay? We are using a block here called labels, and this cluster has two different labels: secret type equals cluster and environment equals staging. So I want my application to be deployed in this cluster. I don't want to deploy my application in local Kubernetes cluster. I want to deploy my application in this specific cluster because of these two labels. So list gen okay, appset-1. I didn't save the new file. Okay, very good. So in this example, I want my application to be deployed only in the new cluster, not a local cluster, because we are using selector and match labels. Okay, very good. Let's see how it's working. kubectl apply -f appset2.yaml. Okay, first of all, let's delete the previous application set appset1. Good. And let's apply the new file. Delete. Okay. As you can see, we have an application called external-application, and this application is deployed in the new cluster only because we have one application. The namespace is cluster-generator. First of all, I want to check this namespace in my local Kubernetes cluster, getNF. Cluster-generator is for the previous example. Get all-n cluster-generator. We have no resources in this namespace. This namespace is created for the previous example. But what about the new cluster? If I type kubectl get all-n cluster-generator, you can see we have some resources in this namespace. So we deployed our application in the new cluster only using match labels and selectors in cluster generator. The cluster generator will automatically target both local and non-local clusters. For every cluster that matches the cluster selector. If you wish to target only remote clusters with your applications, for example, you want to exclude the local cluster, then use a cluster selector with labels. For example, if you see appset2, we are using a selector with two different labels: environment, called staging, and secret type cluster. For example, I want to delete this file. Very good. Let's open it again. If I remove environment called staging, it still will deploy in new cluster only. Let's prove that. kubectl apply -f appset2.yaml. You can see that we have single application only here, and this application is deployed in the new cluster only because we are using a label called secret type called cluster. This selector will not match the default local cluster, since the default local cluster does not have a secret. It's important. Default local cluster does not have a secret. However, if you do wish to target both local and non-local clusters while also using label matching, you can create secret for the local clusters within Argo CD Web UI or using CLI. First of all, I want to delete this application set. Okay. Let's create a new secret, but in this time, I want to create the secret for the local Kubernetes cluster. Let's copy from secret.yam to secret-local. The name is local. The environment is pre-staging, for example. And it will also use this label, secret type equals cluster. By default, local cluster has not any secret. Local, and the server address is kubernetes.default.s3c. I remove bearer token and CA data. Okay. First of all, I want to type kubectl cluster list. You can see that we have two different clusters. The first cluster is local Kubernetes cluster. It has not any secret. The new Kubernetes cluster has a secret and it has two different labels. Secret type equals cluster and environment equals staging. We created a new secret-local, and I want to use this file for the local Kubernetes cluster, and it will have two different labels, secret type equals cluster and environment equals pre-staging. For example, let's apply this secret file. Okay, and as you can see here, the name of the cluster has been changed from in-cluster to local. So now this local Kubernetes cluster has a secret, and this cluster has two labels, secret type equals cluster and environment equals pre-stage. So if I go to the new directory cluster generator, in this time, if I apply this manifest with this selector, secret type equals cluster, this application will be deployed in both of the clusters because the local Kubernetes cluster has a secret now, and it has a label like this. So this application will be deployed in the both of the clusters now. Let's prove that. I type kubectl apply -f appset2. We have no applications here. And yes, we have two different applications, local application and external application, because the local application has a secret with secret type equals cluster label. Very good. In this time, I want to deploy the application in local Kubernetes cluster only. So what should I do? I type kubectl delete -f appset2 to delete the previous applications from here. Okay. Let's open the new file appset2. But in this time, I want to use another label called environment, and the local Kubernetes cluster has a label called environment equals pre-staging. Okay, so it means that this application will be deployed in the local Kubernetes cluster only. So if I type kubectl apply -f appset2, you can see that the application is deployed in the local Kubernetes cluster. And the name of the application is local-application. So if I type kubectl all-n cluster generator, we have some different resources here. But in the new cluster, if I type it again, we can see that no resources found in the cluster namespace because the application is deployed in the local Kubernetes cluster only because of this selector. Okay, very good. And for the last example related to cluster generator, I copy the content. Let's create a new file called AppSet 3. Okay. In this time, we are using values. You may pass additional string key value pairs via the values field of the cluster generator. Values added via the values field are added as values dot something. For example, path, values dot path, values dot namespace. For example, here we are using name as a parameter and also server. And what about namespace? What about namespace? In the previous example, we used a namespace called cluster generator. But in this time, I want to set a variable for the namespace. For example, the value related to namespace for the local Kubernetes cluster here is pre-staging NS. And for the new cluster is staging NS. We have two different clusters, so we have two different elements here, clusters and clusters. The values for the new cluster for the namespace is staging NS. And for the local is pre-staging NS. And the syntax is like this. Values.namespace. Values.path. Like this. So these two applications are using different namespaces and different paths because of values that we used here. Okay, let's apply this new file, AppSet 3. Very good. No, let's delete the previous application first. AppSet 2. Okay. Good. And yes, we have two different applications, local application and external application. But in this time, we have two different namespaces. If I type kubectl get_ns in local Kubernetes cluster, we have a namespace called pre-staging NS. And here in the new Kubernetes cluster, we have a namespace called staging NS. So the name of the namespaces are different because of values that we used. Very good. It was about cluster generator and Argo CD. In this time, I want to talk about Git Generator. The next generator is Git. In the previous examples, we talked about clusters and destinations. We deployed our applications into multiple clusters using list and cluster generators. But in this time, I want to focus on sources. Let's go to the Git repository, okay? We have a new directory called Git Generator. we have a subdirectory called resources. Let's go to it. Okay. And here we have two different resources. The first one is Nginx helm, and the second one is Nginx manifests. For example, I want application A to use Nginx-helm as its source. And I want application B to use Nginx manifests as its source. What should we do? What can I do? The first way and the first solution is creating two different applications. Application A will use Nginx helm as its source, and application B will use Nginx manifest as its source. So I will have two different applications. But it's not ideal. The recommendation is using Git Generator and Argo CD to create a single Kubernetes manifest and generate multiple applications based on the directories that we have in this path. Very good. Let's go to Git Generator directory. We have a subdirectory called directory-subtype. Let's click on the first example. I copy the content. Very good. Let's create a new directory called git-gen. Let's create a new directory called directory. You have two different subtypes in Git Generator, directory and file. The first one is directory. Let's create a new app set. Okay. Very good. In this time, we are using a new generator called Git. It wants repo URL. This is the URL of the repository that I want to use. DevOps hobbies, Argo CD tutorial. The revision is main, okay? In this time, we have a new field called Directories, and it accepts us some different path. The path is this: v09 Argo CD Applications set-1 / Git Generator / resources /star. I'm in resources path. We have two different directories in resources directory. So we will have two different applications. The first application will use Nginx-helm as its source. And the second application will use Nginx-manifest as its source. This generator, Git Generator, will automatically provide us some different parameters. The first parameter is path. What is the value of this key? The path of the first application will be like this: Argo CD Applications set-1 / Git Generator / resources / Nginx-manifest. And the path of the second application will be ApplicationSet-1 / Git Generator / resources / Nginx-helm. This is the value related to a key called path. But what is the path.base name? This is the most right path name. For example, this is a path: Argo CD Applications set-1 Git Generator resources Nginx-helm. This is a path. But what is the value of path.base name? Nginx-helm or Nginx-manifests. These are the values related to path.base name. The name of the first application will be nginx-manifests-application. And the name of the second application will be nginx-helm-application. These two applications will be deployed in the local Kubernetes cluster. And please attention to the namespace. We are using path.basename here, namespace. So the namespace of the first application will be nginx-manifest-ns, and for the second one will be nginx-helm-ns. Very good. We have no applications here right now. I type kubectl apply-f appset1.yaml. As you can see here, we have two applications, nginx manifest application and nginx helm application. And if I type kubectl get ns, you can see that I have two different namespaces, nginx helm ns and nginx manifest ns. So we have two different directories here, so we will have two different applications too. It was about the first subtype of Git Generator called directory. Okay, it was about the first example, but what is the second example? Let's copy the content here and let's create a new file called appset-2. Okay. As you can see here, I'm using two different paths, resources/star. But I want to exclude one or more specific path of the first path. For example, in the resources, we have two different directories. I want to exclude nginx manifest, so I will have one application only, because nginx-manifest is out of this application set. Okay, let's save the file. Very good. Appset-2. kubectl delete -f appset1 appset1 and the application has been deleted from Argo CD environment, and let's create the new file kubectl apply-f appset2. And as you can see, we have one application only here, nginx helm application, because nginx manifest is the path that has been excluded in the manifest. Very good. The Git file generator is the second subtype of the Git generator. The Git file generator generates parameters using the contents of JSON or YAML files found within a specified repository. Okay, we have a directory called directory. I want to create another directory called files. Okay, let's go to the Git repository here. The second subtype is files-subtype. I copy the content of this example and paste it here. Very good. Let's save the file, but before that, let's delete the previous application set. Very good. Okay. I said that the Git file generator generates parameters using the contents of JSON or YAML files found within a specified Git repository. In this time, I'm using files instead of directories. Okay? We have a path, v09 Argo CD Applications set-1, okay, /Git Generator /cluster-config. Cluster-config, okay? We have two different directories here. For example, let's click on staging directory. We have a JSON file. This is the information about the new Kubernetes cluster that we have in Argo CD environment in a staging directory. And in pre-staging directory, we have config.json, and this is the information about the local Kubernetes cluster. So we are using this path to extract all the files, all the config.json files related to this path. We are using $* here. It means that the path here doesn't matter for us. Okay. We are using some different parameters here. Cluster.name, cluster.path, address, and namespace. The content of config.json are parsed and converted into template parameters. For example, this is a JSON file. This is a config.json file. I copy the content. Let's go to the node. I copy the content. Git Generator. First of all, Git Generator converts this JSON file to some different templates. It will convert this JSON file to a format like this. Cluster dot name, cluster dot path, cluster dot address, and cluster dot namespace. Okay. Git Generator converts the config.json content into some different templates, some different parameters like this. Cluster.owner. Okay. Because of that, when you see this manifest, we are using cluster.name. For the first application, it will use pre-staging directory. We have a directory here called cluster-config. We have two different directories. we are using a star. It means that the content of this path doesn't matter. We have two different directories. The first application is using pre-staging directory and config.json here. Git Generator converts this JSON file to some different parameters. So the first application is using cluster.name. Cluster.name here will return a value like this, pre-staging. And for the second application, the cluster.name will be staging. Okay? We are using cluster.path like this, cluster.path, cluster.path, cluster.address, cluster.namespace. Okay? The first application, the name of the first application will be pre-staging application. The name of the second application will be staging application. The first application will use this path as its source, and the second one will use another path as its source, like this. The first application will be deployed in default Kubernetes cluster, and the second one will be deployed in this Kubernetes cluster. The namespace here is staging NS, and for the first application is pre-staging NS. So we will have two different applications, staging dash application and pre-staging dash application. First of all, let's apply this file, kubectl apply -f appset1. Okay. As you can see here, we have two different applications, staging and pre-staging applications. Staging application is deployed in the new Kubernetes cluster with here kubectl getNS staging -ns, and for the first application the namespace is pre-staging ns, as you can see here. Okay, so this application is deployed in the new Kubernetes cluster, and pre-staging application is deployed in the local Kubernetes cluster, and it's because of this config.json. So Git Generator converted this JSON file into some different parameters. Very good. It was about Git Generator. Okay. In the next section, for the next session, I will want to talk about a matrix generator, merge generator, and pull request generator. But that's enough for this session, and I will see you soon.